Hi everyone, so today we are going to be able to identify key characteristics, graph and write equations of sine functions. So the first thing we're going to do is look at the sine function and just be able to evaluate at certain angles. So the first one is 0, so the sine of 0 we know is 0. The sine of pi over 2 we know is 1. The sine of pi we know is 0. The sine of 3 pi over 2 is negative 1, and the sine of 2 pi we know is 0. So we can go ahead and just plot these points on my little graph here. So we have 0, we have 1, we have 0, we have negative 1, we have 0. So if we connect these, what we're going to notice is we actually make sort of a repeating wave pattern. And keep in mind that these will continue if you were to continue on either values here and actually going the other way. They're just going to make this same wave pattern. So you need to know that the sine function has this sort of wave pattern. It kind of does look like an S. The domain is going to be negative infinity to positive infinity, and that range is going to be from negative 1 to a positive 1. Now, of course, this is always going to change based on any vertical shifts and any vertical stretches or shrinks. So now we're going to review these transformations. Now, you might remember these transformations are actually from our functions unit. So when we were looking at graphs, we were looking at vertical stretches and shrinks, horizontal stretches and shrinks, and any types of shifts going either the horizontal or vertical direction. Now, when you're looking at trig functions, we are going to be looking at the same idea, but they're just going to be called something different. So when we're looking at vertical stretches, we're looking at sort of our amplitude. So that's the distance between our sort of midline to the very top of our graph or our wave to the very midline and to the very bottom. So remember, if let's say your A value happens to be a negative number, we're taking the absolute value of that. So that's always going to be positive. When we're looking at the B value, that's relating to what's called our period. And that is the time to complete one cycle. So from one wave kind of starting off, going down. So that is one period. So one sort of S wave. So the next thing we'll look at connecting with horizontal shift would be our phase shift. So how we're moving in the horizontal direction. And our vertical shifting is also called our midline. So that's sort of the value that cuts horizontally your graph in half. So that's called your midline. Now, the thing that you must remember is that your B value must always be factored out, especially if there's a value for C that's not 0. So that's just going to be able to help you identify your shifts and transformations a little bit easier. So let's go ahead and sort of determine all these key characteristics. We're going to graph at least one period from each of our functions here. So the first thing we want to do is you always need to know that for sine graphs, we always start at 0. And then depending on our vertical shifts, we're going to go either up or down. So here, the first thing that you'll see is that our vertical shift, which is called our midline, pertains to our value here at the very end, which is going down 5. We're also going to look at our amplitude. So that amplitude is the A value, the absolute value of A. So that's a positive 2. So that's the distance from our midline to the top or the midline to the bottom. The next thing we'll go ahead and look at is, again, our period. So we're going to look at 2b over our b value. And then with this one, our b value is 1, right? That number in front of x. So 2 pi over 1, which is just the same thing as 2 pi. And then we'll look at our phase shift. Now our phase shift, we don't have any horizontal shifting. So we're just going to write none. Okay, so now we're going to go ahead and look at all of these key characteristics and put them on a graph here. All right, so the first thing that we want to do is we want to remember that we're always starting at 0. That's where sine starts at. But then because of our vertical shift, that 0 is going to be down at -5 because we're going down 5. That's where we're starting. And that is where our midline is. So now what you're going to go ahead and see is that because of our amplitude, so the amplitude is 2, when we look at -5, we're either going to add 2 to go up, or we're going to subtract 2. And that's going to give us a -3 and a 7. So kind of at the top here, we're going to have -3. So that's kind of our high point. And then at the bottom point, we're going to have -7. So now we're going to look at where we're starting with our 4 tick marks relating to our period. So our period is 2 pi. Half of that is going to be pi. We don't have to find the other two middle. We just want to be able to find sort of the start, the end, and sort of our midpoint, which is our average of our tick marks. Now, what we're going to go ahead and see is we're also going to see that we don't have any shifting for our phase shift, so we're okay there. No C value there. So remember, it's going to look like an S, so it's going to look something like this. So our pi and the end of our period are going to be the same. So we're going either up to that highest point, which is -3, coming back down to hit that pi, going to that lower point, which is going to be that -7, going up to hit that -5. Okay, so we're going to actually do question number 3 before we think about having to factor out a B value. So let's look at these. Our vertical shift again. We're looking at the end, that is going to be a +3. So we'd go up 3. We're going to identify our amplitude, which is 4. We're going to look at our period, so that's 2 pi over B. So that's 2 pi over our B value, which is 2, which is just pi. And then our phase shift, we're looking here. Remember, inside's opposite. So I'm going to go to the right, pi over 2. So now if you look at your graph here, okay, so the first thing we want to do is say, okay, we know we should start at 0 because that's our sine graph, but because of our vertical shift, we're going to go up to 3. Our amplitude is 4, so I'm either going to go 3 and then I'm going to go up 4, which is to 7, or I'm going to go 3 and I'm going to go down 4, which is to -1. So again, we're just taking 3 and we're either adding 4 or we're doing 3 and -4 to find the top to the bottom of our wave. Now, as we figure out our period, we're going to go ahead and do 1, 2, 3, 4 tick marks. And then pi, half of that is pi over 2. So we have our tick marks there. The other thing you want to remember is that your phase shift is going to the right pi over 2. So pi over 2 is actually 2 tick marks. So I'm going to go 2 tick marks over. So pi and plus another pi over 2, that's 3 pi over 2. So remember how we are starting and sort of doing our graph here. Now our graph, again, is that sine. So we're starting up, coming down. So it should look something like that. So here we go. We're going to look at starting off at 3, because again, like that's where your midline is. So at 3, we're going to start, and then we have pi over 2, and then at pi, and then at 3 pi over 2. So the start, the middle, and the end are all going to be that same 3. We are going to go up to our 7 value, come back down to our 3 value, go down further to the bottom, it's -1, going back up to 3. Now, again, remember that these do continue, right? This is a repeating wave pattern. So you could keep drawing more than one period. So again, just kind of going back down and waving up. All right, so here we have example 2. We're going to do our vertical shift, which is then here our midline. So I don't have anything here at the end. So it's actually none, which is the same thing as y is equal to 0. That's where we're starting. You're going to notice that you do have an amplitude of 3. Your period is 2 pi over b. And so that's 2 pi over, well, we have to make sure that we factor out our b value. So we're going to factor out that 2. And you're going to get 2 and then x minus pi. So our b value is 2, which is going to get me a period of pi. Here we can see our phase shift a little bit easier, right? So we're going to go to the right. We're going to go pi distance. So here, let's go ahead and graph. Now we're starting off again. We're starting off at 0, no shifting, so we're good there. Now, when we do our period, we've got 1, 2, 3, 4. This is pi. Half of that is pi over 2. Our period is pi only, but then our phase shift is, again, we have to go to the right pi. So pi is worth 4 tick marks, right? So I'm going 1, 2, 3, 4. Another pi, which I know is going to get me 2 pi. So here we go. We're going to go ahead and see that we're going to start at 0, going an amplitude of 3. That's going to be 3. And it's going to be negative 3. So we're going to look at where we are starting. So we're going to start here at pi. We're going to go every other. It's going to hit right at that 0. So we're going to go up to the value of 3, come back down, come down to the negative 3, and then right back up to 0. So you can do more than one period if you'd like, because again, you have that repeating wave pattern. So you would just go like down, come back up to pi over 2, kind of work your way backwards, back up, and coming back down where we start at 0, right? And go back up like a wave. Okay, so here we have our next example. Again, here our vertical shift right here at 5. So we're going up 5. My amplitude is the absolute value of my A, which is a positive 3. Important thing for you to know is that negative is actually a reflection, right? It's the reflection over your x-axis. Your period, 2 pi over b, and you've got 2 pi. Your b value is pi, so our period is worth 2. And our phase shift, we do not have anything, so it is a none. So let's go ahead and figure out what our graph is going to look like. So here we go. All right, so we are going to be, remember, always starting at 0, but we're going to go up 5. There we go. So again, that's like your midline there. We're going to go ahead and see our amplitude. So our amplitude, I'm either going to go up 3 to 8, or I'm going to go down 3 to 2. Let's move this just down just a hair. All right, so we've got our period, 1, 2, 3, 4 tick marks for one cycle. That's 2. Half of that is 1. So we know as we are doing our points here, we're going to start at 5, the halfway point, the midpoint at the end, right? They're all going to be along that midline. So the important thing to remember is that normally our sine graph would look like this, right? This would be 8, and this would get you to 2. But because we're reflecting over the x-axis, we're going to like jump. So the values that you actually have for your top and the bottom of your wave is actually going to flip. So I'm going to go down here to 2. I'm going to go back up to that 5. I'm I'm going to go up to that value of 8, coming back down to that value of 5. Okay, so here we're going to go ahead and write a sine function that has a specific amplitude of 3. So you have sine. Your amplitude is 3. 3 is going to be in the front. That's like your vertical stretching or shrinking. You're going to get a midline of -4. So that's going to be on the outside at the very end. And then you're going to get a period of 3 pi over 5. Now your period, remember, is 2 pi over b. So when you get your period and you see that you have 3 pi over 5, we can go ahead and solve that to get our b value. So we can cross multiply. That's 10 pi over b times 3 pi. So you can divide by 3 pi. Pi is going to cancel. So my b value is 10/3. So 10/3, it's what's going to go in front of x. I do not have any phase shift, so here is my answer. Here we are asked to determine the minimum and maximum value of this trig function. So what we are really looking at is our midline. And we would either add or subtract our amplitude. So we're going to take that -4 and we're either going to add or subtract 5 to it. So that's going to give us our high and our low points of our wave. So if I do -4 plus 5, I'm going to get 1. And if I do -4 minus 5, I'm going to get -9. So my minimum is -9 and my maximum is 1. So you can really think about it as your range. Your range is going from -9 to 1. So this last example we're giving you is a picture of a trig function, and we want you to be able to write the equation from it. So the first thing you want to do is see that I can actually find out where I am starting. So normally in a sine graph, you're going to be starting at 0. But here I'm actually starting at -1. So my graph is going up, going kind of back to that 0, that midline here, going down and coming back up. So here's my midline. And then I have a high point and my low point. So as you're writing your equation of your sine function, let's think about what you have. If you have your midline, and your midline is at y is equal to -1, you've gone down 1, that means you're going to get a -1 here at the end. The next thing we want to do is we want to find the amplitude. So the amplitude, make sure, is your midline to your top or the bottom. So that distance is going to be 4. So that amplitude goes in the front. That's a vertical like stretch or shrink location. And the last thing we want to do is figure out what the period is. So the period is from here, this 0, going all the way up, down, till it gets kind of back to that same -1 value. That's your period. So I'm going from 0 all the way to pi. So 2 pi over b is equal to my period, which is pi. So pi times b equals 2 pi. If I divide by pi, so then b is equal to 2. So my period is going to be 2. So I'm going to have 2 in front of my x. Okay, I hope this video was helpful. You're able to now understand more about sine functions and its graphs. Don't forget to like and subscribe so you can learn even about the cosine graph. Thanks for watching and have a great day.